Bismillahirrahmanirrahim. Elastic and inelastic collisions. A collision in which the kinetic energy of the system is not conserved is called the inelastic collision. For example, when two tennis balls strike with each other or collide with each other, then their shape deforms and they get compressed during the impact process. And during this reshaping or deformation, the atoms of the materials of balls slide or slip over one another and they get rubbed with each other. The atoms of the materials of the ball get deformed, and during friction, due to friction of the atoms movement, the loss of energy occurs during this collision. So this collision is inelastic collision, while in the ideal case when no kinetic energy is lost, the collision is said to be perfectly elastic. For example, a solid ball when strikes the solid surface or the solid floor and it pushed or comes back to the same height almost without the loss of energy, then ideally we can say that this collision is perfectly elastic collision. Elastic and inelastic collisions in one dimension. For the sake of elastic and inelastic collision, we should analyze two parameters, momentum and energy, mechanical energy or kinetic energy. It should be remembered that momentum is conserved in any collision, elastic and inelastic, but the mechanical energy is only conserved in the elastic collision. And more precisely, perfectly inelastic collision, after colliding, particles stick together, there is a loss of energy because of the deformation. And this type of collision, when the particles stick together, is called perfectly inelastic collision. And what is the elastic collision? Particles bounce off each other without loss of energy. Then this type of collision is called the elastic collision. And similarly, in the case of inelastic collisions, but not perfectly inelastic, just inelastic collision, particles collide with some loss of energy but did not stick together. This is a case of inelastic collision. In the case of perfectly inelastic collision, particles stick together just as shown in figure. Before collision, the balls were separated and coming towards each other for collision process, and after colliding, if they get stuck, then this type of collision is known as perfectly inelastic collision. During the process of perfectly inelastic collision, momentum of the system remains conserved as shown in the figure and as shown in this equation, while there is a loss of kinetic energy. So the initial kinetic energy is not equal to final kinetic energy unless we write the term of E loss for equality process. It should be observed, it should be noted that the balancing of this equation, momentum equation, only could happen because of the multiplication of heavier, more mass. Initially, before collision, both balls were not so much heavy, or they have individual masses, m1 individual and m2 individual, multiplied with the respective velocities. But now the resulted velocity is multiplied with the more mass. Because of this more mass, the momentum of the system remains conserved. but velocity decreases, net velocity of the system actually decreases. So final velocity is not so much as compared to V1 or V2. So momentum of the system is conserved because of the sticking process, while energy of the system is actually lost because of the deformation process. If they get stick together, then this type of collision is known as perfectly inelastic collision. We move further on the next slides. In case of elastic collision of the two particles, we are aware of that momentum is always conserved. Momentum is conserved in any elastic and inelastic collision, but energy is only conserved in the case of elastic collision. So elastic collision follows two laws: law of conservation of momentum and law of conservation of energy. Now we derive some mathematical relationship between the initial velocities before collision and the final velocity after collision for both the balls. Before collision and after collision, what are the velocities of both balls? They are related with each other. With these mathematical relationships, we are going to prove these mathematical formulas. For this purpose, we take the law of conservation of momentum. As we know that, as shown in figure, before collision, the both balls were having the mass m1, velocity v1, mass m2, velocity v2. So total momentum was m1 v1 plus m2 v2 before collision. But after collision, the momentum will be m1 v1 dash and m2 v2 dash. So as we have considered that this is elastic collision, so two laws, law of conservation of momentum and law of conservation of energy, remains valid. For first law, law of conservation of momentum, this equation is valid. And from this equation, by rearranging the term, we can write the equation 3-14. For the conservation of kinetic energy, law of conservation of kinetic energy, we know that total kinetic energy before collision is half m1 v1 square plus half m2 v2 square. And after collision, the velocities get changed. They get v1 dash and v2 dash. So total kinetic energy will be changed. But the sum of kinetic energies will be equal to the kinetic energy before collision. And by multiplying with 2 to the both sides of the equation, these 2 is get cancelled and we only get the relationship m1 v1 square minus mv1 dash square. As we have moved the m1 containing terms to the left hand side and m2 containing terms to the right hand side, and getting common m1 as common, we get the result. And we can also write this equation into the 3-15 form, as a square minus b square can be written as a plus b into a minus b. So v1 square minus v1 dash square can be written as v1 plus v1 dash into v1 minus v1 dash. Similarly, second. Now, by dividing equation 2 or 3-15 with the equation 3-14, m1 get cancelled in the left hand side and v1 minus v1 dash get cancelled. In the left hand side, only v1 plus v1 dash remains in the left hand side, and similarly on the right hand side, v2 dash plus v2 remains. And if we rearrange these terms, we can write V1 minus V2 is equal to V2 dash minus V1 dash. And further, getting negative sign common, we can write this. And this shows that if initially V1 was, if we consider V1 is equal to 10 meter per second, the second ball is moving with a 4 meter per second, means first ball will approach to the second ball with the 6 meter per second, as initially M1 was moving with the speed of 10, M2 was moving with the speed of 4. The difference is 6. It means M1 is getting closer in every second with a value of 6 meter per second. M1 is approaching M2 with a speed of 6 meter per second. But after collision, negative sign shows that M1 is getting away or recessing, or V2 is moving fast with the speed of minus 6. And they are getting recessed, or they are moving away from each other. It means speed of approach and speed of recession are equal but with opposite sign. Initially they were getting closer, and after collision they are getting separated with the same velocities. In the case of elastic collision, it only happens in the case of elastic collision, then that when two balls collide, the speed of approach is always equal to speed of recession. Now, from these equations, 3-14, 15, and this last equation, we can derive the terms, these formulas. How? Just only by putting the value of V1, V1 dash and V2 dash, by just eliminating the values, we get these formulas. So after some simple mathematical steps, by using the equation 3-14, 3-15, and this last equation, we can deduce these results, that V1 dash or V1F is equal to the right hand side, and similarly V2 dash is equal to this right hand side. It is easy to remember these equations. Please just look at this. It's very easy to remember that always M1 plus M2 is always in the denominator in all factors. But in case of V1 dash, we have to take M1 minus M2 with the V1. And in case of V2 dash, we will take the not M1 minus M2, but just M2 minus M1 put in the second term. So it's very easy to remember. M1 plus M2 is always in the denominator, 2M2 in first case and 2M1 in the second case. So it's very easy to remember. Always remember these equations for the case of elastic collision and for the purpose of exams. As we have derived these equations, from these equations we can further analyze the process of elastic collision in 4 cases. Case number 1, if masses are equal in the collision process, then what happens to the velocities after collision? If we consider that velocities before collision were V1 and V2, with the same masses, m1 is equal to m2, then what will be the velocity after collision? v1 dash and v2 dash. So put m1 is equal to m2, same values will cancel. m1 is equal to m2. If m1 is 5 minus m2 is 5, 5 minus 5 is 0, this term will cancel out. And m2 is 5, 5 into 2, 10. If m2 is 5, okay, just we consider the mass 2 is 5. Yeah, as m1 is equal to m2, and we consider m1 is equal to m2 is equal to 5 kg. Then 5 into 2, 10, or 5 plus 5, 10, 10 will cancel 10. Then the result will be v1 is equal to v2. v1 dash is equal to v2. It means velocity after collision will be of the first ball will be equal to the velocity before collision of the second ball. If m1 was moving with the 10 velocity and m2 was moving with the 4 velocity, now the blue ball will be moving with the 4 velocity, and after collision red ball will be moving with the 10 velocity. Velocities are just only interchanged or switched. Okay, so we have discussed the first case. Now we move towards the second case. Second case is in such a way that if m1 is equal to m2 and the second ball is at rest, then after collision, by using these equations, we can get the values of velocities after collision. Just putting the value, these two terms will cancel out, and putting the value of m2, just only let me take m2 is equal to 5, then 10 over 10 will cancel, and as we know that v2 is equal to 0, second ball is at rest, so v1 dash becomes 0. It means that v1 dash becomes 0. So the first ball will stop after collision. In case 2, first ball will stop after collision, and the second ball will move with the velocity v1. It means if blue ball was moving with the 10 meter per second speed and the red ball was at rest, then after collision the blue ball will become at rest and the red ball will move with the same velocity of the value 10. Case 3. In this case, we take second ball is at rest and it is a very heavy mass as compared to the first one. m2 is very greater than m1 and heavy mass is at rest, and m1 is a very lighter ball. It is lower in mass. The value of m1 is very smaller than m2. In this case, if you apply the values, as v2 is small and m1 is almost negligible, by putting the values we get the result. As v2 is 0, put v2 is 0, the whole term becomes 0. v2 is 0, the whole term becomes 0. Only first two terms remain. Now put the value of m1 is equal to 0. m1 is equal to 0. It will become m1 is equal to 0. It means that m2 over m2 cancel, minus v1 is the answer. And in the second case, as v1, m1 is equal to 0, the whole term becomes 0, v2 dash is equal to 0. It means that the ball, smaller or very lighter ball, will collide with the heavy ball and it will repel back with the same velocity without affecting the heavy ball, or The heavy ball still remains at rest, but the lighter ball comes back with the same velocity. Now the last case, case 4. In this case, we take a very heavy ball collides with a very smaller value of mass or very lighter mass. What happens in this case? Let's see. As we know that these two equations, and we put the values as we have considered, v2 is equal to 0. So the two terms become 0. And m2 is almost 0. So m2 is 0 means m1 over m1 cancel. v1 dash is equal to v1. It means the heavy ball, blue ball, will continue its speed, no effect on the blue ball. But the lighter mass, v2 dash, means the velocity of the lighter mass after collision will be equal to, by putting the value of m2 is equal to 0 and m1 will cancel m1, it will only remain 2v1. So v2 is equal to 2v1. It means the lighter mass will move with the speed double to the speed of the blue ball after collision. Thank you for watching the lecture. Please visit the website www.kencollege.com for more information.